Okay, so we're going to switch to breathing now. Hopefully the neuro exam went well. If it didn't, you know you have an optional final that you can take to replace that grade. So that's good. And now you have a better idea of what the exams in here are like, and so it should go really well from there. So again, hopefully you did well. The quizzes should have prepared you pretty well for the questions that were on the exam, but if you didn't do well, you know you've got ways to make up those points. All right, so breathing. The way I want to start breathing is first we're going to talk about kind of like overall movements and forces and lung volumes that we're going to be talking about that I want you to have kind of in your mind while we talk about these other things on here, the anatomy, the neural control, the speech production, and the clinical concerns. And also, a quick note about the clinical concerns. I do talk about those at the end, but they're also kind of throughout the lecture, right? So we're going to talk about ribs in the second lecture in breathing when we talk about the anatomy, and I'm going to talk about a clinical concern that goes along with ribs. So like I'll compile a few at the end, but then there are some throughout. So be mindful of that when you're studying your clinical concerns. So like if you go to yoga a lot, what I want you to do is like focus on your breath. Don't close your eyes and lay on the floor though. I mean, you can lay on the floor, and I guess you can close your eyes too. So do whatever. But what I want you to do is just focus on normal breathing right now. So take in a breath and feel your rib cage, your chest, your up here. So with normal breathing, there's not a whole lot of movement going on with the rib cage, just like quiet, relaxed breathing. But now feel your abdomen. That should be moving quite a bit. So what direction is it going? As you breathe in, what happens? So your abdomen moves out, right, when you breathe in. And it comes back when you breathe out. Think about why that is. We'll discuss it through the rest of this, but think about why it is. Now what I want you to do is breathe in a lot. Take in a large breath. Now feel what your ribs do. They should move kind of outward, up. They should kind of like, the whole rib cage gets larger. You kind of feel that, right? And then, so it expands, yeah, like I said. Now feel just your sternum. This one's a little bit less pronounced. I'm not sure that you can feel it exactly, but you should be able to feel it kind of moving outward a bit, kind of hinging, maybe up and out. I can feel mine a little. Like if you feel right down here at the very end of the sternum, you can feel it kind of move out just a little bit. It's not a huge movement. It's not nearly as noticeable as the ribs, but I mean the ribs move a lot, but the sternum moves a little bit. Okay, so what we've got here is this is your diaphragm. This is the main breathing muscle. We'll talk about it more when we talk about muscles, but it's like if you were asked the question like what is the muscle involved with breathing, it's the diaphragm. So remember that for the exam. Of course there's others. We're going to talk about other muscles that are involved in breathing, but like the most important breathing muscle is the diaphragm. All right, so what it does, it's kind of hard to understand for some people. And like I said, we'll talk about it more when we talk about muscles. But what's going to happen with the diaphragm? It's a muscle. And it is not connected to the lungs, but it helps the lungs work. So what happens is the diaphragm is going to contract. When the diaphragm contracts, it pulls down. And that's what these arrows are showing here. The diaphragm is going to pull down. So what that does is it creates more space. You can see it here also. So this is right here. This is when the diaphragm is completely relaxed. When you breathe in, the diaphragm pulls down. So the diaphragm is going to pull down, and it's going to create like kind of a negative space inside, and the lungs are going to expand to fill that space. If you need to take in more air than just the diaphragm contracting, that's why you're moving your rib cage. So then other muscles come into play. They lift and expand the rib cage. The rib cage, I should say, you can see right here, it's kind of always in this like kind of relaxed, somewhat flattened, kind of hanging down state, right? So gravity's just kind of pulling down on our rib cage a little bit. And then we have muscles, which again we'll talk about, that will pull up on the rib cage. They'll tighten, it'll lift the rib cage, make it more straight out. See how these ribs here are a little straighter, like more straight out from the body. So they'll come out straighter, and that opens up the thoracic cavity even more. So you've got the diaphragm is contracting and moving down. The rib cage is coming up more straight to make a more open, spacious area, and then that is going to allow even more air to fill up the lungs, right? So remember, think about one of the first things in the first lecture was, what direction do muscles move? Muscles can only contract. That means they're going to get shorter when they're innervated, right? So that when they're used, they're going to get shorter. And what that does is it will pull in whatever direction that muscle is shortening, right? So they can only contract, they can't pull. It's going to come into play when we talk about the diaphragm. Remember that. But essentially what's going on is the thoracic cavity is undergoing these pressure changes from opening up and having negative pressure, air flows in, relaxing, then you have positive pressure, air flows out. That's kind of how it functions. The lungs actually don't have any muscle tissue in them whatsoever. So when air flows into your lungs, it is a passive process for the lungs. It's not a passive process for your body, but for the lungs it's a passive process. They are along for the ride. Okay. So you can see these are a couple of things that are going on. Like I said, the ribs will go from their kind of normal, kind of hanging down, lazy state, and then they become elevated. That makes more area inside the thoracic cavity. The sternum here also kind of levers outwards. This is why you can feel it more right here at the very bottom of your sternum, that it's kind of hinging outward, is because it does kind of hinge like this pump handle, right? So this part up here is not moving a whole lot, but down at this end, it's moving a lot more. Not as much as the pump handle, but you can see that it's moving a little bit. That's because, again, the rib cage is getting larger. It's coming more straight out, so the sternum would kind of move upwards as well. All right, so that's what's happening when you breathe in. Think about why does your abdomen move outwards when you take in a breath? Well, the diaphragm's moving down, right? So the diaphragm is pushing down. Where's all the stuff going to go that is below the diaphragm? It has to get pushed out. So you take in a large breath, your abdomen moves out, you breathe out, all that stuff can kind of go back to where it was. All right, cool. So we've got a couple different forces at work, right? We've got passive forces and active forces. So one of the things that happens when you move a muscle, when you contract most muscles, so let's think about the arm again, like we talked about last time. So when you move the arm like this, we're pulling on this muscle. This muscle is contracting. So actually your bicep connects up here, and right about here-ish, I think. So it's going to span this distance. It lives here, but it spans the distance. So it pulls, and it's going to pull the arm in. Well, what's happening? It's stretching the skin here. It's stretching the other muscle that's here, your tricep. It's stretching the tricep. It's stretching tendons, ligaments, stuff like that. In the lungs, we've got lung tissue that's being stretched as well. So these are all passive forces. They're being stretched, but it's because we're activating this. So when we let this muscle go, one of the things that happens is all these things that are being stretched, they want to go back to not being stretched, just like a rubber band, right? So you pull it out, you're using muscular force to pull the rubber band, it's along for the ride. Once you let off, it wants to go back to where it was. That's true for things that are opposing muscular movement as well. Another thing that we have is gravity, right? So gravity's always kind of pulling down on the ribs a little bit, and so that's going to pull down. So think about those. We'll talk about the spring, right? So here's the spring at equilibrium. It's just a spring. You can push it down, but then the passive forces are going to want to push it back up towards equilibrium. You can stretch it out, but then the passive forces are going to want to pull it back down towards equilibrium, right? So it's got one state that it likes to be in. This is true for the lungs as well. And not just the lungs, but also the thoracic cavity and the muscles that help pull air into the lungs, the diaphragm and the muscles of your rib cage. So those are the active forces, though, right? Diaphragm, the rib cage muscles, and the abdominal wall. So think about it again. The diaphragm contracts. The diaphragm's going to move. Let's see, you can't see that. The diaphragm's going to move down, and the air is going to come into the lungs, right? So the lungs are stretched out. Let's say it's a huge breath, so you're also using your rib cage muscles to pull up on your rib cage. And so then when you let the breath out, you're not using any muscles to let the breath out if you just let the breath out. So go ahead and do it. Take in a huge breath and then just let it go. And so what's happening is gravity's pulling down. The tissue that's stretched out in your lungs is contracting. The diaphragm is relaxing and popping back up to the place it likes to be. Okay, but now take in another breath. And now use your, engage your abs to, push the air out. So that's one way that you can push extra air out. You can push the air out faster than it wants to just flow out naturally by using your abdominal muscles. And that's it's a two-step process, sort of, because the abdominal muscles are going to push against all the junk that's inside your abdomen, which is then going to force the diaphragm back up, which is then going to shoot the air out of your lungs, right? Okay, so the equilibrium state, when your lungs are in the same place as this spring right here, is called your resting expiratory level, or your resting expiratory end level, but I usually just go with resting expiratory level. So the way that you can judge this is taking a breath and let it out. And without forcing more air out, and before you take in another breath, that is your resting expiratory level right there. That's going to be important as we go through this lecture. You can think of your lungs kind of as a bellows, although, I live in Arizona and I don't really, I don't have a fireplace. I don't know if many of us that live here do, but you might live elsewhere, so maybe you have a little bit more familiarity with these. But the bellows volume is the lung volume. It's kind of along for the ride, right? The actual volume in there. So what's going on is you actually have to use muscular force to pull the bellows open and push it out, right? So to take in all the air it can, you have to do that. To push out all the air that can be pushed out, you have to do that as well. But then there's a spring, good old spring. And what that spring does is it kind of keeps the bellows in an equilibrium state. If you push it all together and force all the air out, it's going to pop back out a little bit. If you pull it all the way out and then just let go, it's going to push the air back out and go back to its resting expiratory level. So you can think of it that way if that helps. So more about volumes that you can have in your lungs. We've got our resting expiratory level right here. Your normal tidal volume is your typical breath. So typical quiet breath is what it's called. So maybe as you're sitting here listening to this lecture, you're just breathing in and breathing out a little bit, just comfortably. That is your tidal volume right here, or quiet breathing is what that's also called. Tidal volume usually just uses the diaphragm only. So it's a very kind of efficient process. You're only really using one muscle. And again, you're only really using one muscle when you breathe in. When you breathe out, the diaphragm is just relaxing, and gravity and the other elastic forces are pushing the breath out. So you're really only using one muscle and only in half of the cycle, just while you're breathing in. That's tidal volume. Oh, well, I guess I should have highlighted it for you with this slide. Now, inhale your normal amount and then keep going. All the way, as much as you can, right? So, that is your inspiratory reserve volume, or IRV. So that's when you're going to take in all the air that you possibly can, right? Maybe if you have the hiccups, you're doing your entire inspiratory reserve volume. That's the maximum amount of air that can possibly be pulled into the lungs. This is usually measured from resting expiratory level. I'm not going to ask you a question about, like, calculate these numbers. I'm going to ask you more like what it is. So you don't necessarily need to know that it's measured from resting level. That's typically how it's measured, though. So if you do focus on breathing as an SLP, you should know that. But I won't ask you on the exam. So, and we've got a couple more, though. So now breathe out. Now breathe out all the way. You're going to have to use your abdominal muscles all the way out. That is your expiratory reserve volume. So it's hard to do that when you're also trying to lecture. That's the maximum amount of air that you can actually push out of your lungs. Okay, so I think this picture probably gives it away, but do you think that your lungs are completely deflated when you push all the air out that you can? They're not, right? Maybe you said that. Maybe you did. But anyway, there's definitely some air left in the lungs when you've pushed all of the air out that you can. It's called reserve volume. It's what's left in there at the end of a maximum expiration. So there's always some amount of air that we can't get rid of, right? The lungs are never completely deflated, and that's probably a good thing. So those are volumes, but what about lung capacities? So your total lung capacity is the volume that is in your lungs after a maximum expiration. It's everything. It's all this, right? It's your reserve volume, it's your expiratory reserve volume, it's your tidal volume, and it's your inspiratory reserve volume. It's all of them. Your vital capacity is actually going to be the amount of air that you can actually control, right? So it's going to be all of the volume that you can push out or pull in. So everything but your reserve volume. Your inspiratory capacity, well, I guess I didn't have anything for that. Your inspiratory capacity is going to be the maximum amount of volume that can be inspired from the end of a tidal cycle. So it's essentially the same thing as the inspiratory reserve volume. And then your functional residual capacity, this is kind of a weird one. Your functional residual capacity is what's left at the expiration of a normal tidal expiration. So after quiet breathing, when gravity has just done its job to, push the air out of the lungs, functional residual capacity is everything that you can push out and everything that is left. So that's functional reserve capacity. This is a great slide to study for anything that I ask about volumes and capacities on the exam. Okay, it's a little bit different for speaking. This kind of shows the different kinds of things that we would do. It's all in percentage of change for the lungs, right? Because 0 is your maximum expiration that you can do, so it's your expiratory reserve volume. You've got this unusable range that this isn't even measuring. So it's not percentage of actual lung volume, it's just percentage of your vital capacity, right? So 0 on this scale is what you could possibly push out. And then there's some things on here that are a little bit weird, like expiration during vigorous laughing. I'm not totally sure I've ever heard the expiration vigorous laughing. I guess that, like, laughing while you're jogging, maybe? I'm not really. I don't know. Your usual relaxation at the end of a quiet breath is about 40. Resting tidal inspiration is about 50. Different charts I've seen would put that at about 55. But it's somewhere between there, resting tidal inspiration. And then you can see, here's where it gets different for speaking. When you start to speak, you're going to pull in more breath than you do during a normal tidal breathing cycle, right? So it's going to come up to about 60% of your vital capacity. So to start speaking, you're going to prepare more air than just normal breathing. During loud reading, you're going to breathe in even more. If you are a opera singer, you're definitely going to pull in more. And then also during vigorous yawning, which seems like an oxymoron because you're yawning vigorously somehow. And then your maximum inspiration, again, when you have the hiccups, usually that's when you actually use your maximum inspiration. So all that to say, you're using a different amount of air when you're speaking versus really trying to project your voice versus singing classically versus just normal tidal breathing. Okay, so here's where we're going to switch gears a little bit and go back to the thoracic cavity and the air that's inside. Something called Boyles Law. Well, I'll get back to that in a second. So let's talk about the air has a certain amount of pressure, right? You've heard of air pressure, barometric pressure when you watch the weather on the news. And it's about 15 pounds per square inch. That's kind of like a global average. It's different wherever you are based on atmospheric conditions and based on temperature. But that's like a rough average. So molecules like to be evenly dispersed. You probably know this from chemistry, right? Diffusion, dispersion. All molecules like to be pretty much evenly distributed, right? So like a nice... like a good piece of toast, right? It doesn't have like a glob of butter in one place and then no butter elsewhere. It's like perfectly covered everywhere, but not by too much, right? Well, I guess even if you like tons of butter on your toast, you would like it evenly spread. It'd be kind of... Anyway. I mean, at what point do you just have bread with... Anyway. So the molecules like to be evenly dispersed. Right, they might start in a larger concentration in one area, but pretty soon they're going to diffuse. It's going to be an even concentration throughout the entire container, whatever is containing these air molecules. That's true in the lungs as well. And so local pressure in the lungs is going to change with the size of the cavity, right? Molecules like to be evenly distributed. So if you look at this picture, you've got this plunger kind of pulling up on this glass chamber, and it's making more area inside the beaker, and it's giving more room for the air molecules to move around. What is that like? It's kind of like, if you flip it upside down, the plunger is a lot like the diaphragm, right? So as you breathe in, the diaphragm moves down. That means that there's a lot more room for the air molecules in here to take up. That means that there's less pressure than there was before. So when there's less pressure, that means that there might be a negative pressure relative to the outside. You can imagine that if you, let's say that when we filled this glass beaker, the plunger was somewhere between these two, between pushed all the way in and pushed all the way out. So it was about here. And what we did was we opened like a little valve down here and just kind of let in the same amount of air that's outside, right? Then we close the valve, it's all self-contained, and we pull the plunger down. Now there's negative pressure in there. The pressure is less inside the beaker here than it is outside the beaker. That means negative pressure. When there's negative pressure, you kind of set up like a vacuum. So it's going to try to like pull on everything that it can pull on, right? It's actually not really pulling on it. I mean, it kind of seems like it's pulling on it, but really what's happening is the pressure outside is pushing on the walls of where there's less pressure. You'll see why this is important in a minute. And then if you do the opposite, so when you breathe out all the way, use your abs to like push all the air all the way out. Now you're pushing all these air molecules together. And now in here there's more pressure than there is outside. So now there's positive pressure in here. They want to escape. Obviously they can't in here. So now they're pushing on the walls outside. They're going to push on everything that they come in contact with. So how does this work with the lungs? Well, hang on one second. We'll get there. So what I want you to know from this is Boyles Law. Pressure times volume is a constant. It equals a constant, right? So you can see that here the volume is greater. And if there's a constant, let's just say 6, right? So if the volume in this case is 3, we can see that there's more volume here than there is here. So if the volume in this case is 3, and the constant, it's always a constant, it's going to be a constant here and here. The K is going to be the same, no matter what. So let's say K is 6. But if volume here is 3, that means pressure is 2, right? Because 2 times 3 equals 6. So pressure is 2. But now we've reduced volume to 2. We've pushed it down. Now it's 2 units. It was 3 over here. Now it's 2 units. Well, pressure has to raise to accommodate that drop in volume. So now the constant is 6. It's always 6. So now pressure is 3. So you can see that pressure has increased here. If we pushed it even more down to just 1 unit instead of 2, well, pressure would be 6 because the constant is always 6, right? So that is really important to know for the quiz and the exam, Boyles Law. And I might have you compute it, but it's going to be with simple numbers that you should be able to do in your head. All right, so how does this work with the lungs? Well, here's a model of your body, like part of your body, your thoracic cavity, your abdomen, your lungs, your trachea, the diaphragm's in here too. Your trachea is this little tube. The trachea, we'll talk about it when we go to anatomy, but it's just, you know, this air tube that runs down and connects to your lungs. It's kind of a passive thing too. It's like a straw. You can think of it like a straw. The lungs we talked about are passive. You can think about them kind of like just a balloon, right? It's here. It doesn't have any muscles to make itself inflate to take in air. That's not happening. What has muscles are the diaphragm and then also the edges of this thoracic cavity. I'm not really going to use them in this demonstration, but you can imagine that they're doing something as well. Down here you've got your abdomen and like all your goo in your stomach, and then here's the lungs, like I said. All right. So right now, let's say this is like the end of normal tidal expiration. Everything's balanced. All the pressures are equal everywhere, right? Pressure here is equal to pressure here is equal to pressure out here in the world. There's probably differences in pressure down here, but that's a whole other part of anatomy we don't even need to worry about. So what we need to worry about is pressure in the lungs, pressure in the thoracic cavity, pressure in the outside world. This is where all the air is, right? This is the outside of your mouth or nose. They're all equal in this moment. Thanos is pleased. Okay, so now you start to breathe in. You can see what happens. The diaphragm moves down. Now you've got negative pressure here. Why is it negative pressure? Well, volume has increased, which means pressure has to decrease. Negative pressure. One thing I want to stress about this is like an instantaneous thing. It's not like your diaphragm moves and then your lungs take, you know, a few minutes to fill up. It kind of moves together instantaneously. So you really have to think about this as kind of like, you know, we're really taking like snapshots, and I'm really over dramatizing the difference in pressure so you can see it. These things happen much more rapidly than it seems like they do in this. But anyway. All right. So the diaphragm moves down because you're breathing in. Now you've got negative pressure in the thoracic cavity. This is where what I said about positive pressure and pushing on the outside, all of the positive pressure is pushing on where there's negative pressure, right? So the air that can come into the lungs, this has positive pressure now because you've got negative pressure here. This is the same pressure as the outside because it just came from this state where everything was balanced. So now this is less pressure. This has equal to the outside, but it's positive relative to the thoracic cavity. So all of the molecules in here are pushing on the outside of the lungs. They're pushing to make the lungs expand. Also, down here you can see that we've moved the diaphragm down so that all this stuff is getting compressed. So then your stomach has to kind of move out to accommodate that. Air's pushing on the outside, on the inside surface of the lungs because it has higher pressure. It's pushing on it, pushing on it. They expand. Again, this is just a snapshot in time. So it's still, this is between when it's totally inflated. So the lungs still have positive pressure relative to the thoracic cavity. But now they have negative pressure relative to the outside. So now what happens? Well, all this air outside is pushing on this. Air is going to want to come in. So this is just, it's continuing to move, right? So the lungs fill up. Now it's equal, the pressures are equal between the thoracic cavity and the lungs, but we're still negative relative to the outside. Air has to rush in to fill this up. And now everything's equal again. Now we're at this state. So the thoracic cavity has gotten larger. The lungs, air pressure is pushing on the lungs to take up the space that's been opened up in the thoracic cavity. Air comes in because of that negative pressure, and then when you're at the top of an inhalation, everything's equal again. But then you decide to breathe out. You can see the diaphragm moves up. You've got negative pressure here, so the stomach comes back in. You can see that the thoracic cavity is getting much smaller. So all of the air molecules that are in your thoracic cavity are now pushing on the outside surface of the lung. They're just kind of like, it's kind of like if you're, you've got a balloon and you're really, you're just gripping it really tight. You're pushing on it, right? So it's equal pressure relative to the outside, but there's positive pressure. This is not true. This shouldn't say that this has positive pressure relative to the outside. This has positive pressure relative to in here. Sorry about that. The thoracic cavity has positive pressure relative to the lungs. It's pushing. It's got higher pressure. So then pushes the lungs to get smaller. The air comes out of the lungs, and then we're back in the place where we started. Everything's equal again. And then this whole cycle starts over. All right. We talked about the movements of the abdominal wall, right? As the diaphragm moves down, the abdominal wall moves out. If you tighten up your abs and pull in, then the diaphragm has to move up. And then the last thing that I want to say here is we'll talk more about the movement of the rib cage. We did a little bit, but we'll talk more. So you can see that you can move the rib cage or you can move the abs. Usually it's a little bit of both. And this is kind of the resting area that we like to be in. But you can, let's say you're at the beach, right? And you're shirtless, or you've got like, a really nice new bikini on, whatever. And it's the beginning of summer, so it's still like closer to Thanksgiving than later in the summer. You know what I'm getting at here. So maybe you're going to like tighten your abs the whole time, right? You don't want to be exposed without your abs being tightened. Well, you can still breathe when you do this, right? This just means that instead of being able to let your abs come out, move in and out with your breath, now it all has to come from the chest, right? Your ribs have to move up and down. So I can hold my abs constant. And then the ribcage wall is going to have to move. So hold the abs constant. And you're kind of breathing just with your chest. If for some reason you wanted to do the opposite, you could. You can hold your chest constant and just kind of breathe through your abs. Don't do that on the beach. I don't recommend it. I mean, even if you're like really in shape, you're going to look like you're not because of all this, air that you're breathing in and you're expanding your abs. Anyway, so you can do one or the other. Usually we do a little bit of both. There's less work involved. There's less stress put on either system when both are used. But you can emphasize one over the other. Okay, that's it for this lecture. We'll move on to anatomy in the next one.